In this video, I'm going to show you how we can solve non-homogeneous second-order linear differential equations with the method of undetermined coefficients. Let us start with a simple example. Consider this differential equation: y double prime minus 3y prime plus 2y equals to 2x squared minus 8x plus 5. We say this differential equation, this second order differential equation, because we have double prime, we say this is a second order linear differential equation. We say this differential equation is non-homogeneous because the other side of this equation is non-zero. If you remember, when the other side of this equation is 0, we don't have this here and this equals 0, the differential equation is homogeneous. But this differential equation is a non-homogeneous differential equation. The general solution of a non-homogeneous differential equation y, the general solution, is always equal to y sub c plus y sub p. But what is yc and what is yp? Y sub c is the complementary solution, is the solution that we can find from the homogeneous corresponding equation for this equation. So, y sub c is the solution of the homogeneous equation. So for finding y sub c, we have to solve the homogeneous equation. The homogeneous equation corresponding to this equation is y double prime minus 3y prime plus 2y equal 0. So, always the first step for solving non-homogeneous differential equations is to solve the homogeneous differential equation. We have to set the other side of the equation equal 0. So first, for finding y sub c, the complementary solution, we have to find the solution of this homogeneous equation. If you remember, for solving the homogeneous second order differential equation, we have to write the characteristic equation r squared minus 3r plus 2 equals 0. This is the characteristic equation for this differential equation. For finding r from this characteristic equation, we have to factor this equation, or we can use quadratic formula for finding r. But because this is really simple, we can factor it like this. And from here, r equals 1 and r equals 2. Because here we have two distinct real roots, the complementary solution, the solution of this homogeneous differential equation, y sub c equals to c sub 1 e to the first root, which is 1x, plus c sub 2 e to the power of 2x. If you want to learn more about how we solve homogeneous differential equation, you can watch my video about homogeneous second order and higher order differential equations. After we find the complementary solution, then we can find the particular solution for this differential equation. The particular solution is the solution that depends to the function in the right side of the equation. So for finding yp, we have to look at this function, and it depends to the right side of the equation. But note that the complementary solution is not dependent to this right side. Always we set this equals 0 for complementary solution. But the particular solution is the solution, is part of the general solution that depends to this part of the equation. In the method of undetermined coefficients, for finding the particular y, we look at this function, and based on this function, we try to guess what type of function can satisfy this equation. Here we are looking for a function that second derivative of that function minus 3 times first derivative of that function plus 2 times the function equals to this quadratic equation, equals to this polynomial, second degree polynomial. the only function that derivative of that function and the function itself and second derivative of that can equal to this polynomial can be a quadratic equation. So, because in the right side of this equation we have a quadratic equation, we have a quadratic function, we guess that the particular solution must be a quadratic function. It's completely reasonable. If in the other side, in here, instead of degree 2, we had degree 3, we can guess that the particular solution should be a polynomial of degree 3. If this is degree 4, the particular solution is of degree 4. So, in the method of undetermined coefficients, based on the function on the other side of the equation, we guess the particular solution. Later in this video, I will describe that actually we are not guessing. There is a rule for writing this particular solution in general. But for a moment, suppose we are guessing. But there is a reason behind this guess. Because here is polynomial, it's reasonable that the particular solution also be a polynomial of the same degree. So, we say the particular solution should be something like ax squared plus bx plus c. But note that we don't know these numbers. We don't know what is a, what is b, what is c. Don't think that a is 2, b is negative 8, or c is 5. No. These a, b, and c are unknown numbers. And the reason that we name this method the method of undetermined coefficients is that these coefficients are undetermined. And we have to determine these coefficients. But how we can find a, b, c? For finding a, b, c, just we have to plug in this equation. We replace this y with this function. We take derivative of y, we replace for y prime. And we take second derivative of this, we replace y prime by that, y double prime by that. So, before doing anything else, let's find y prime and then y double prime. The derivative of this polynomial is 2ax plus b, and second derivative is 2a. Now for finding ABC, we have to plug in these in here. We replace y double prime with 2a minus 3 times y prime, so 3 times 2ax plus b, plus 2 times y, 2 times this, 2 times ax squared plus bx plus c. And this should be equal to this. So this should be equal to 2x2 minus 8x plus 5. But how we can find ABC? It seems that we only have one equation with 3 unknowns. A is unknown, B is unknown, and C is unknown. How we can find 3 unknowns from only one equation? We can simply find unknowns by equating the coefficient of x squared, coefficient of x, and the constant on the two sides of the equation by each other. Let me show you what I mean by equating coefficients. Before doing anything else, let's multiply these 3 in the bracket, 2 in this bracket, and simplify the left side of this equation. So we have 2a minus 6ax minus 3b plus 2ax2 plus 2bx plus 2c. It should equal to 2x2 minus 8x plus 5. Note that we have only this term with degree 2. So we have 2ax squared. We have this term with x and this term with x. So coefficient of x in the left side is negative 6a plus 2 times yx. And these are the constants in the left side. 2a minus 3b plus 2c. 2a minus 3b plus 2c. And this equals again 2x2 minus 8x plus 5. Now, if you look at the right side and the left side, because we want this expression to be equal to this expression, so the coefficient of every term in the right should be equal to coefficient of the corresponding term in the left. This means equating left side coefficients with right side coefficient. For example, what is coefficient of x squared in the right? 2. What is coefficient of x squared in the left? 2a. So 2a must be equal to 2a equals 2. Now let's go for x. What is coefficient of x here? Negative 8. What is coefficient of x here? Negative 6a plus 2b. This should be equal to negative 8. And finally, 5 is the constant in the right side. But what is the constant in the left side? This expression. 2a minus 3b plus 2c. Now from this system of equation, we have 3 equations with 3 unknowns. Simply we can find a, b, c. From the first equation, simply you can find a. A is 1. If we plug in 1 in the second equation, we can find b. A is 1, so we have negative 6 times a. Negative 6 times 1 is negative 6 plus 2b equals negative 8. From this equation, 2b equals negative 2, and so b equals negative 1. This is the value of b, and a is 1. Now if we plug in 1 for a and negative 1 for b in this equation, we can find c. 2 times a, 2 times 1 is 2. So we have 2 times 1, 2, minus 3 times b. B is negative 1. Negative 3 times negative 1 is positive 3. Plus 2c equals 5. 2 plus 3 is 5. And in the other side also we have 5. If we move this 5 in the left to the right, 5 minus 5 is 0. So 2c is 0, and so c is 0. Now we have all of the coefficients, the value of all the coefficients, a, b, c. We can plug in these values here to find the particular solution. So if we plug in these values in y sub p, the particular solution equals to a is 1, so 1x2, b is negative 1, so minus x, and c is 0, so plus 0. This is the particular solution. And here we find that the complementary solution is this. Now, for the general solution, note that y is the general solution, and general solution is the sum of complementary solution and the particular solution. So the general solution of this differential equation, y equals to c sub 1 e to the x plus c sub 2 e to the 2x plus, this part is complementary solution, plus particular solution, x squared minus x. And this is the general solution of this non-homogeneous second order linear differential equation. Now that we are a bit familiar with the method of undetermined coefficients, let me show you how we can apply the method of undetermined coefficients for any non-homogeneous differential equation in general. The general form of a non-homogeneous second order differential equation is something like this: ay double prime plus by prime plus cy equals f of x. In the previous example, f of x was a polynomial of degree 2. We can apply the method of undetermined coefficients for only 3 types of functions. So we have some restriction when we want to use the method of undetermined coefficients for non-homogeneous differential equations. F of x must be one of these 3 types of functions. F of x can be a polynomial or an exponential function or sine, say sine of bx or cosine of bx. Not any trig function, only sine or cosine. So we have restriction for f of x. If f of x be any function other than these, we cannot apply the method of undetermined coefficient for solving non-homogeneous differential equations. Let me show you some examples of each of these type of functions. Polynomials like the previous example, or something like 2x2 minus 1, 3x plus 7, x to the 3 plus 2x2 plus 10x plus 100. These are different polynomials. This one is degree 3, degree 1, degree 2. All of these are polynomials. Probably you know what polynomial means. Exponential functions. F of x can be something like e to the 2x, e to the 3x, e to the negative x, and functions like this. So f of x can be of these type of functions. And finally, f of x can be sine or cosine, but not sine of anything, sine of bx. Sine, for example, sine of 2x, cosine of 3x. B can be any real number. Sine of 5x, cosine of x over 2, and functions like this. And I should add this. F of x can be any combination, any linear combination of these or product of these functions. For example, let me show you some examples of combinations or product of these functions. For example, f of x can be something like this. 2x plus 3 times cosine of x. If we have f of x in this form, it's completely fine because this part is a polynomial and this part is of this type. This is a product of a polynomial by sine or cosine. Or, for example, f of x can be something like x2 minus 4 times e to the 3x. Polynomial times by exponential. Or other combinations, which you can make. E to the negative 2x times cosine 7x. Exponential times cosine. Or we can have more complicated functions. Something like x2 plus 3 plus 2x minus 1 times e to the x plus x2 cosine x. F of x can be this function. Note that here we have a polynomial. This part is a combination of a polynomial exponential, and this part is a combination of polynomial and cosine. So these are examples of what f of x can be. And only for these type of functions we can use this method. Don't forget this. For example, if f of x be something like tangent of x, ln of x, reciprocal functions like 1 over x, square root of x, cube root of x, and functions like this, unfortunately, the method of undetermined coefficients doesn't work. So don't apply this method for these type of functions. It's very important. We can find the particular solution only when f of x is of these type of functions. Now that we are a bit familiar with this method, let me show you how this method works by some more examples. Y double prime minus 9y equals to 5 e to the power of 2x. This is a non-homogeneous second order differential equation. And in the right side of the equation, we have an exponential function. So we can use the method of undetermined coefficients. First, we have to find the solution of the homogeneous differential equation. Then we can find the particular solution. Don't forget that the general solution is the sum of complementary solution, the solution of the homogeneous part of the equation, plus the particular solution. For finding the complementary solution, first we set the differential equation equals 0. For the complementary solution, we don't care about right side of the equation. We set it equal 0. For solving this, we write the characteristic equation. R squared minus 9 is 0, and from this, R is simply plus minus 3. And because we have two distinct real roots, the solution, the complementary solution, is c sub 1 e to the 3x plus c sub 2 e to the negative 3x. After we find the complementary solution, now we want to find the particular solution. Because in the right side of this equation we have an exponential function in the form of e to the 2x, we can guess that the only function that's the second derivative of that function minus 9 times the same function can be equal to e to the 2x is only e to the 2x, because you cannot find any other function except e to the 2x that derivative of that function or second derivative of that function to be equal to e to the 2x. So for finding the particular solution, it's completely reasonable to choose yp, the particular solution, to be a factor of e to the 2x. So we guess that the function, the solution, should be something like e to the 2x, but we don't know what factor of that. So we put an unknown here, a coefficient here for e to the 2x. Don't forget, this is the method of undetermined coefficients. So always we put coefficients, unknown coefficients. Now for finding this particular solution, first we have to find second derivative of this. Y prime is, a is a coefficient, we have to take derivative of e to the 2x. Derivative of e to the 2x is e to the 2x. Multiply by derivative of 2x. Don't forget chain rule. Derivative of 2x is 2. So derivative of a times e to the 2x is 2a to the 2x. Now if we find second derivative of this equals to 4a e to the 2x. Similar to the first step, if we take derivative of this, derivative of e to the 2x again is e to the 2x multiplied by derivative of 2x, which is 2. 2 times these 2 is 4. Now if we plug in this for y double prime, we have 4a times e to the 2x minus 9 times this. It should be equal to 5e to the 2x. 4a e to the 2x minus 9a e to the 2x is negative 5a e to the 2x. And it should be equal to the right side. Now again, if we equate the coefficient of e to the 2x in the right with coefficient of e to the x in the left, the coefficient of e to the 2x in the right is 5, and in the left is negative 5a. From this, a is negative 1. Now if we plug in negative 1 here, the particular solution is negative 1 e to the 2x. And so the general solution y equals to complementary solution, which is c sub 1 e to the 3x plus c sub 2 e to the negative 3x plus the particular solution, plus negative e to the 2x, which is negative e to the 2x. And this is the general solution of this differential equation. Now let me show you another example. Y double prime plus y prime minus 2y equals 3 cosine x minus sine x. We have a non-homogeneous second order differential equation, and f of x is a combination of sine and cosine. This example is again a relatively simple example. First, we have to find the complementary solution. So the first step, as usual, is to set the equation equal 0 for finding the complementary solution. For solving this equation, we have to find the characteristic equation r squared plus r minus 2 equals 0, which if we factor this, we can write this as r plus 2 times r minus 1 equals 0. From this, r is negative 2 and r is 1. These are simple real roots and they are distinct real roots, so the complementary solution is c sub 1 e to the negative 2x plus c sub 2 e to the x. Now for finding the particular solution, we have to look at the right side of the equation. For finding the particular solution, note that in the right side we have trig functions, sine and cosine. And remember that derivative of these type of functions, derivative of sine and cosine, is again sine or cosine with some negatives. So we can guess that the only function that second derivative of that plus derivative of that minus 2 times that function that can be equal to cosine or sine is again sine and cosine. You don't know any other function that derivative of that functions be equal to sine or cosine. So it's really easy to guess that the particular solution should be a combination of cosine and sine. And don't forget, this is the method of indeterminate coefficients. So just put cosine x and sine x here with some unknown coefficient, a cosine x, b sine x, or a sine x, b cosine x. The order doesn't matter. It's completely up to you. But now we have to try to find a and b. We have two unknowns. For finding these two unknowns, again we have to find y prime and y double prime. Derivative of y prime is, derivative of cosine is negative sine, so negative a sine x. And derivative of cosine is cosine plus b cosine x. Y double prime is negative a cosine x minus b sine x. Now we can plug in these here. Y double prime is this. So we have negative a cosine x minus b sine x plus y prime plus this. So minus a sine x plus b cosine x, and finally minus 2a. So minus 2 times this, multiply 2 by this, so minus 2a cosine x minus 2b sine x, and this should be equal to, so this should be equal to this 3 cosine x minus sine x. Before doing anything else, let's simplify a bit this part of the equation. We have negative a cosine x plus b cosine x minus 2a cosine x. So what is coefficient of cosine x in the left side? Finally, note that for cosine x, the coefficient we have negative a, b, and negative 2a. So we have b minus 3a as the coefficient of cosine x. Negative a minus 2a is minus 3a. And what's coefficient of sine of x? The coefficient of sine of x is negative b, negative a, and negative 2b. Negative 2b minus b is negative 3b minus a. So minus 3b minus a is the coefficient of sine of x. And this should be equal to 3 cosine x minus sine x. Now again, as the first example, we have to equate coefficients. Coefficient of cosine x here must be equal to coefficient of cosine x here. So we have b minus 3a equals 3, and negative 3b minus a equals negative 1. Now from this system of equation, we have to find a and b. Again, it's completely up to you which method you want to use to solve this system of equation. Elimination method, substitution method, or any other way. You can also guess b and a. For solving this system of equation, here I use the elimination method. First, I multiply this by 3 to make coefficient of b positive 3. If I multiply this equation by 3, we have 3b minus 9a equals 9. And we write the second equation here. Now if we add these two equations, negative, this cancels with this, so nothing from b remains. Negative 9a minus a is negative 10a. And 9 minus 1 is 8. So from this, a equals 8 over negative 10, or 4 over negative 5, which is negative 4 over 5. And now if we plug in this value in this equation, or in this equation, we can find b. If we plug in this value of a here, we have b minus 3 times this. We have multiplied 3 by this. So minus, don't forget we have a minus here and a minus here. So if we multiply this minus by that minus, we have plus 12 over 5 equals 3. If we bring this to the right side and we do a simple common denominator, let me show it here for a moment. b is 3 minus 12 over 5. Note that if we give one denominator to 3, we can make it 5 and make this 15. 15 minus 12 is 3. So anyway, it seems that b is 3 over 5. Now that we have the value of a, value of b, we can write the general solution. So the general solution of this differential equation is, so the general solution y is y complementary c sub 1 e to the power of negative 2x plus c sub 2 e to the x plus this, but attention, a is -4/5, so plus -4/5, which you can write it simply as -4/5. It's better. So -4/5 cosine of x plus 3/5 sine of x, and this completes the solution of this differential equation. I hope by watching this video you have learned a bit about the method of undetermined coefficients. Note that these examples were really simple. In the next videos, I will show you more complicated examples. By more complicated examples, I mean the equations that the function in the right side of the equation are more complicated. And in those examples, we have to learn more tricks. Here, if you notice, for writing the particular solution, we had no difficulty. But in the next videos, we will see examples that when we write the particular solutions, sometimes in the particular solutions, we have terms that are common with the complementary solution. And in such cases, we have to multiply x by the particular solution such that the complementary solution and the particular solution have no common term. In the next videos, we will talk about these in more detail. So, till the next video, goodbye and thank you for watching.